In this video, I will introduce the concept of the intersection of sets. So suppose we have two sets, A and B. We can then define the intersection of A and B, which is represented by the symbol A intersect B. And the intersection is defined to be the set consisting of the elements that are in both A and B. So what this means is that X is an element of A intersect B if and only if X is an element of A and X is an element of B. So X needs to be an element of both A and B. And we can express this idea using set builder notation by writing A intersect B is equal to the set consisting of the elements X such that X is an element of A and X is an element of B. Now let's take a look at an example. Suppose A is the set consisting of the numbers 1, 3, and 5, and B is the set consisting of the numbers 1, 2, and 3. In that case, the set A intersect B is the set consisting of the numbers 1 and 3. And that's because 1 and 3 both show up in both A and B. So you can understand the intersection of A and B as the set consisting of the common elements of A and B. And since 1 and 3 both show up in both A and B, that's why 1 and 3 are included in A intersect B. Let's take a look at another example. Suppose this time A is a set consisting of the numbers 1 and 2, and B is a set consisting of the numbers 3 and 4. In that case, A intersect B is the empty set, because there are no common elements between A and B. In other words, there are no elements that show up in both A and B. As you can see, 1 and 2 show up in A, and they don't show up in B. 3 and 4 show up in B, and they don't show up in A. So there are no common elements, which is why A intersect B is the empty set. And whenever the intersection of two sets is equal to the empty set, we say that the two sets are disjoint. So being disjoint means that the two sets have no common elements. We can also derive several identities concerning intersections, just like we did for set union. For example, the intersection of a set with itself is just equal to itself, and also the intersection of a set with the empty set is just equal to the empty set, because there are no common elements between A and the empty set, because there's nothing in the empty set, and so that's why A intersect the empty set is just equal to the empty set. And also the intersection of A and B is equal to the intersection of B and A, so just like set union, set intersection is also commutative. And also set intersection is associative, which means A intersect B and then intersect C is equal to A intersect the intersection of B and C. And once again, this property, this associative property, is also shared by set union, as we have seen in the last video. Now that we know about unions and intersections, we can also form identities that combine the two. The most important identity is the distributive law, and the distributive law states that A union B intersect C is equal to A union B intersect A union C. As you can see, the A union symbol has been distributed to both B and C, so you're moving this A union symbol to the B, and then you move this A union symbol to the C, and so you can see that this expression over here has been distributed to both B and C, which is why this is called the distributive law. And you can draw a parallel between this and arithmetic, because we know that 3 times 2 plus 1 is equal to 3 times 2 plus 3 times 1. And you can see that for this case, the 3 times symbol has also been distributed to both 2 and 1. So I'm just taking the symbol and inserting them here. So this 3 times symbol has been distributed to 2 and 1. So you can see that union and intersection, just like multiplication and addition, they both satisfy the distributive law. And there's actually also another distributive law, similar to this one, that reverses the role of union and intersection. So we also have A intersect B union C is equal to A intersect B, the union A intersect C. And as you can see in this expression, the A intersect symbol has also been distributed to both the B and the C. And so there you have it. You have these two distributive laws as well.